Welcome back to Edulexis. Today is day 42, where we unlock the power of polymorphism and method overriding. These aren't just technical terms, they are the secret to building flexible, scalable code. Let's start this journey. Polymorphism literally means to many forms. In Python, it means that the same method name can behave differently depending on the object that calls it. It allows us to interact with different types of objects using a unified interface. Think of a universal remote control. The powered button exists on all remotes. Pressing it might turn on a TV, or a sound system, or a light. The action power is the same, but the result depends on what it's connected to. Method overriding is the mechanism that powers polymorphism. It occurs when a child class defines a method that already exists in its parent class. The child version effectively replaces or overrides the parent's version. Let's define our base class, animal. We define a method called make_sound. In the parent, we'll just print an animal makes a sound. This acts as a blueprint that all animals should have a sound. Now, we define dog, animal. Here, we define make_sound again. By using the exact same name, Python knows we intend to override the parent logic. We print bark instead. Now, dogs bark. We repeat this for cat, animal. Inside cat, we define make_sound to print meow. We now have two distinct behaviors tied to the same method name, make_sound. Create a list, animals equals dog, cat. We iterate through this list using a for loop, calling animal.make_sound. We don't need to check if it's a dog or cat, we just call the sound. Why is this powerful? Python dynamically decides at runtime which make_sound to call. This keeps our loop code extremely clean. If you add 10 more animals, the loop code remains exactly the same. What if you want the parent's logic plus your own? We used super. For instance, in your dog, call super.make_sound first, then print bark. This keeps the original functionality intact. Think of a payment system. A base payment to class has a process method. Credit card payments and PayPal payment both override a process with their unique security protocols, but the app just calls process. This is a key design principle. Code should be open for extension but closed for modification. Polymorphism allows you to extend functionality by adding new classes without breaking existing, tested code. Be careful with typos. If you write make_sound in the child class, you haven't overridden the parent, you've created a new, useless method. Python won't complain, but it won't produce the result you expect. If your code isn't calling the child method, verify the method name spelling. Also, ensure your child class correctly inherits from the parent. Use type to inspect your objects if you get confused. To recap, polymorphism lets us use one name for many forms. Method overriding lets us customize those forms. This makes Python code clean, modular, and easy to manage. Keep practicing this pattern. See you next time.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.